Class 9th, Science CBSE based. Chapter 1, Matter in Our Surroundings. Introduction to Matter. Everything around us, from the smallest particles to large objects, is made up of matter. Matter is anything that occupies space, has mass, and offers resistance to any force applied to it. Physical nature of matter. 1. Matter is made up of tiny particles. Matter consists of small particles that are not visible to the naked eye. 2. Characteristics of particles of matter. Continuous motion. Particles are always in motion, possessing kinetic energy. As the temperature increases, their speed increases due to higher kinetic energy. Space between particles. There are gaps between particles, which allow them to move. For example, when making tea, particles of sugar dissolve into the water, showing that there's space between the water particles. Attraction between particles. Particles of matter attract each other. For instance, the stream of water from a tap cannot be easily broken due to the force of attraction between the water particles. States of matter. Matter exists in 3 primary states: solid, liquid, and gas. 1. Solid state. Characteristics. Solids have a definite shape and volume. They are rigid and incompressible. Solids do not flow easily. Example: a rubber band is a solid, as it returns to its original shape when stretched unless excessive force is applied. 2. Liquid state. Characteristics. Liquids take the shape of the container they are in. They have definite volume but no fixed shape. Liquids flow and can be slightly compressed. Example: water takes the shape of its container but maintains its volume. 3. Gaseous state. Characteristics. Gases have neither a definite shape nor a definite volume. They are highly compressible and can flow in all directions. Example: air, which fills any available space and can be compressed into smaller volumes. Diffusion. Definition. Diffusion is the process of movement of particles from a region of higher concentration to a region of lower concentration until they are evenly spread out. It occurs in gases, liquids, and solids but happens fastest in gases. Diffusion in gases. Key points. Diffusion in gases occurs quickly because gas particles have high kinetic energy and move freely. Activity. Aim: to demonstrate diffusion in gases. Materials needed: a room spray or perfume. Procedure: spray perfume in one corner of the room and wait. Ask students in different parts of the room when they can smell the perfume. Explanation: the scent spreads because gas particles, perfume, diffuse through the air, moving from a higher concentration, where it was sprayed, to a lower concentration. Diffusion in liquids. Key points. Diffusion in liquids is slower than in gases because particles in liquids are closer together but can still move around. Activity. Aim: to demonstrate diffusion in liquids. Materials needed: a glass of water, food coloring. Procedure: add a drop of food coloring to the water and observe how it spreads without stirring. Explanation: the color slowly spreads throughout the water, showing how diffusion occurs as the particles of color mix with the water particles. Diffusion in solids. Key points. Diffusion in solids is extremely slow because particles in solids are tightly packed and have limited movement. Example: over time, if you stack two metal blocks together, diffusion can happen, where atoms from one block gradually mix into the other. This process, however, takes a very long time. Temperature units. Common unit of temperature. The Celsius scale, degree C, is commonly used in everyday life. SI unit of temperature. The Kelvin, K, is the SI unit of temperature used in scientific work. Conversion between Celsius and Kelvin. Formula: K is equal to degree C plus 273.15. K is equal to degree C plus 273.15. Degree C is equal to K 273.15. Example: convert 25 degrees Celsius to Kelvin. K is equal to 25 plus 273.15 is equal to 298.15. Convert 310 K to Celsius. Degree C is equal to 310 to 73.15 is equal to 36.85. Change of state of matter. Phase changes. These are changes in the physical state of matter, solid, liquid, gas, when energy is added or removed. Melting. Definition. Melting is the process by which a solid changes into a liquid when heat is applied. Example: ice melting into water at 0 degrees C. Activity. Aim: to observe melting. Materials needed: ice cubes, a bowl. Procedure: leave ice cubes in a bowl at room temperature and observe how they melt. Explanation: heat from the surroundings is absorbed by the ice, causing the particles to move faster and break free from their fixed positions, turning into liquid. Boiling or vaporization. Definition. Boiling is the process where a liquid changes into a gas when heat is applied, and vaporization occurs throughout the liquid. Example: water boiling at 100 degrees Celsius to form steam. Activity. Aim: to observe boiling. Materials needed: a pot of water, a stove. Procedure: heat the water in the pot and observe bubbles forming at the bottom, eventually leading to steam. Explanation: the heat energy allows water molecules to overcome their attraction and move into the gaseous state. Condensation. Definition. Condensation is the process by which a gas changes into a liquid when cooled. Example: water droplets forming on a cold glass of water. Activity. Aim: to demonstrate condensation. Materials needed: a cold glass of water. Procedure: take a cold glass of water and observe the water droplets forming on the outside of the glass. Explanation: water vapor in the air comes into contact with the cold surface and loses energy, turning into liquid water droplets. Freezing. Definition. Freezing is the process by which a liquid changes into a solid when heat is removed. Example: water freezing into ice at 0 degrees C. Activity. Aim: to observe freezing. Materials needed: water, a freezer. Procedure: pour water into an ice tray and place it in the freezer. Observe the water turning into ice. Explanation: as the water cools, the particles lose energy and arrange themselves into a fixed pattern, forming ice. Matter can change from one state to another by changing temperature or pressure. Effect of temperature. Melting point. The temperature at which a solid turns into a liquid is its melting point. The melting point of ice is 0 degrees C, 273.16 K. Latent heat. Latent heat refers to the amount of heat energy required to change the state of a substance without changing its temperature. During a phase change, such as from solid to liquid or liquid to gas, the heat energy is used to overcome the intermolecular forces, causing the substance to change its state while keeping its temperature constant. Latent heat of fusion. The amount of heat required to convert 1 kg of solid into a liquid at its melting point without increasing the temperature. Boiling point. The temperature at which a liquid changes to gas is its boiling point. Water boils at 100 degrees Celsius, 373 K. Latent heat of vaporization. The amount of heat required to convert 1 kilogram of liquid into gas at its boiling point. B. Effect of pressure. By increasing pressure and lowering temperature, gases can be converted into liquids, and sometimes solids. For example, carbon dioxide gas can be solidified into dry ice. Sublimation. Sublimation is the process where a solid directly changes into gas without passing through the liquid state, and vice versa. Example: ammonium chloride changes directly from solid to gas when heated. Evaporation. Evaporation is the process in which a liquid changes into vapor at any temperature below its boiling point. Factors affecting evaporation. Surface area. Greater the surface area, faster the evaporation. Temperature. Higher temperature increases the kinetic energy, leading to faster evaporation. Humidity. Lower humidity results in faster evaporation, as there is less water vapor in the air. Wind speed. Faster wind speeds increase the rate of evaporation. Evaporation causes cooling. When a liquid evaporates, it absorbs heat from its surroundings, causing the surroundings to cool down. Examples: cooling effect of acetone. When acetone is applied on the skin, it evaporates quickly, absorbing heat and causing a cooling sensation. Wearing cotton in summer. Cotton absorbs sweat and exposes it to air, helping the sweat evaporate and cooling the body. Sprinkling water on the ground. Water evaporates by absorbing heat from the ground, helping to cool the surroundings.